So, the world of cold water swimming found its scientific champion a few years ago.
Hi, my name is Dr. Susanna Søberg, and I have a holistic approach to health and prevention of disease.
A Danish biologist with a PhD in metabolism named Susanna Søberg appeared on the Huberman Lab podcast and began issuing protocols for optimal sauna and cold water immersion with times that were very specific, meant to maximize the benefits of brown fat.
How much cold exposure do people need? How much heat exposure do people need in order to extract these benefits?
See that this was ended up being 11 minutes in total per week, corresponds to being in cold water 1 to 2 minutes at a time, but also in the sauna 10 to 15 minutes at a time.
It was all grounded in her own research on cold water swimmers, most notably this article that landed on the cover of the respected clinical journal Cell Reports. Huberman dubbed her work the Soberg principle.
I just had Susanna Søberg out for a podcast, and she taught me some really interesting things. First of all, this has really helped. I did this.
We should explain that she's the woman who created the Soberg principle.
Yeah. Susanna Søberg did her PhD in Denmark, is I think one of the best scientists in terms of deliberate cold exposure and its benefit.
This video is all about fact-checking that claim and trying to understand why her results are so far off the scientific consensus on the effects of cold exposure, particularly in relation to its fat-burning potential. Of course, with Huberman's endorsement, she rocketed onto talk shows and magazines, and health influencers all around the world, they launched her into stardom. She has since gone on to found the Soberg Institute, which offers training to would-be thermalists to get certified in her own program to the tune of $2,500. That will get them her seal of approval, as well as packages that she has for spas and clinics that want to build institutions in her name. Now, her claims are as impressive as her resume.
The thermalist cure is my take on what I see is needed to lower stress, increase resilience, and prevent lifestyle diseases.
In the advertisement on her Substack, she says that her protocols are the key to health, wealth, and courage. According to her newsletter, her thermalist courses have increased her subscribers' income by 50% and dropped their weight at the same time. Their anxiety has gone away, as has their depression, and now they're more in touch with nature too.
It's biochemistry and physiology that we can explain today. Some of it can be explained in depth, and other processes or pathways we still only know a little about.
Now, for those of you just hearing about it for the first time, many of her claims come down to her expertise on brown fat. And you can think of brown fat as the body's answer to an ever-increasing waistline. Its one role in humans is to suck the white fat from storage and directly burn it for heat energy. It's most active in human infants, but pharma companies have been studying it as a possible weight loss solution in like a pill form with very little success. But ice bathers have long posited that BAT, brown fat, is the secret sauce that lets us resist the cold and maybe even cure metabolic disease. Now, I've written about it too in my book, What Doesn't Kill Us, when the science was much less developed than it is now, and it wasn't clear how this would all shake out. So Soberg's claims, they sound pretty cool, and I decided to dive into her paper to see where her very specific protocols came from to get a better idea of who Soberg really was. The cover article in Cell Reports Medicine came out in October 2021 under the title Altered Brown Fat Thermoregulations and Cold-Induced Thermogenesis in Young, Healthy Winter Swimming Men. Not the catchiest title, but to quote the abstract, the main takeaway should be, quote, our data leverage understanding of BAT in adult human thermoregulation suggest both heat and cold acclimation in winter swimmers and propose that winter swimming as a potential strategy for increasing energy expenditure. And that last bit about increasing energy expenditure, that's code for burning white fat, getting thinner, getting healthier. The study broke down this way. Soberg recruited 8 men with a hobby of winter swimming, as is pretty common in Denmark, and then 8 similar phenotypical non-winter swimmers to compare how the men responded to cold exposure and also sleep afterwards. And in particular, whether or not brown fat played an important role with how they heated their bodies. The two groups were basically comparable, except for one key factor that sort of pops out in the data. The non-winter swimming group, the control group, had about 6% more body fat than the winter swimmers, which means that they had a lot more natural insulation during cold exposure, which will be a factor as we go deeper into this paper. Now, over and over again, she compares the results of the many different tests that she did, and this includes glucose monitoring, thermal imaging, fancy electrodes, and skin temperature tests, as well as subjective assessments about what the comfortable range was of the people when they're feeling cold exposure. Over and over again, she states how difficult it is for her to get usable data, which is a little bit of a red flag, you could say. For instance, in the section talking about her own measurements with an infrared camera on skin temperature, which is a proxy for brown fat activation, she writes, in conclusion, measurements of the supraclavicle skin temperature as an estimate of BAT activity using IRT, which is infrared imaging, should be interpreted with caution. That's another way of saying that she's not sure whether her data means anything at all. In the next section, where she studies glucose uptake, she realized that one of the 8 cold water swimmers that she was studying wasn't uptaking glucose in the way that she wanted him to. And so then she kicked him out of the study and excluded all of his results, writing, quote, "With the aim of detecting BAT-associated physiological variations between subjects, we decided to exclude this one BAT-negative subject from analysis." This effectively eliminated 12.5% of her inconvenient data from her results. And if she's saying that BAT is the critical component for somebody being able to resist the cold water, then one of these swimmers who didn't have a lot of BAT, well, they were still able to swim in that water. So what is she actually studying here? It's actually a huge red flag for me when you just sort of randomly exclude people when the data isn't convenient. But let me go on, because there are more red flags to go. Now, another red flag is that she disagrees with previously published science on how much energy BAT can burn in any one instance, where she notes, and to quote her again, "We observed substantially higher cold-induced thermogenesis in the winter swimming group. Intriguingly, energy expenditure increased by 5,000 to 1,000 kilocalories per 24 hours. It's the rate. Whereas a previous study reported that human BAT would approximately generate 20 kilocalories per 24 hours. Now, this should not just have been a throwaway line in her results. She was saying that in her study, she found that brown fat was burning 2,500 to 5,000% more calories than any other previous scientific study had ever recorded before. Such a claim would throw the entire history of BAT research into a total tizzy, totally upending everything we know about BAT. So, she did cite what that other study was, so I looked it up, and I was surprised that it was conducted by Otto Music, a professor at Wayne State University, who I've actually interviewed on this podcast before while talking about BAT.
A few years ago, people thought that when you are exposed to cold, that brown fat, which is here supraclavicular next to the carotid artery, is activated, and it uses obviously a calorie because it generates heat. And the NIH thought that this will be a good way, a natural way to lose weight. You exposed to cold, you activate brown fat, you lose weight. Now, it actually it was based on studies in rodents where it showed that they lost like 50% of the body weight when you expose them to cold. Now, unfortunately, the rodents are very different, have different evolutionary kind of processes than humans. It turned out that in humans, brown fat is really not important at all, and the amount of calorie you can burn if you have 24 hours, exposed to cold, is something around maybe 20, 30 calories. And a banana has 80 calories.
And I asked Otto about this over text, and this was his response. Hi, Scott. I really have nothing more to say than what I reported a few years ago. Your brain is an organ which uses 20% of all your calories, and it is using 250 kilocalories per day for a 1,400 gram organ. The claim that 150 grams of BAT will use 2 to 4 times more energy than the brain is laughable. People just like to make outrageous claims. Now, I think that's really important to note. When you make extraordinary claims, you need extraordinary evidence, and she doesn't provide that. And elsewhere in the paper, the caveats just keep going. In another part, she says, we cannot conclude from our current data whether BAT lipid turnover is enhanced in the winter swimmer group, which is like exactly what she's been claiming this whole time. Our current data doesn't support that we're burning as many lipids. Okay, so what are you saying? I mean, it could have been absolutely anything causing those differences. And she ultimately concludes that even though she, quote, did not identify a main source of cold-induced heat production in winter swimmers, that winter swimming should probably be a weight loss strategy. Like, what? And frankly, I don't understand how this got published in a peer-reviewed journal. Now, there are two final sections that I want to look at. The first is the limitation section, which is very responsible to put in your scientific paper. And she starts off immediately with the gold standard caveat. We cannot conclude whether winter swimming per se results in increased cold-induced thermogenesis and altered BAT glucose metabolism. Basically saying, I don't know, my paper didn't mean anything. And she's saying this because maybe the people who choose to go cold water swimming a lot have maybe just different biology. Maybe the factors that drew them to cold water were different than what an ordinary people is. And the sample size is admittedly 8, actually 7 after we exclude somebody. So that's a big problem. But she also notes that the control group that she selected was 6% fatter and likely a lot less healthy overall. And her measuring incidents were not all that great. And finally, when she asked people to subjectively measure their own comfort levels during cold exposure, this could be prone to error, which is something that's undoubtedly true since one group goes into cold water all the time and is therefore used to being cold, and the other group never does. Of course, your subjective ratings of being in cold are going to be different. That's going to be natural. So what are we talking about here? The final section that I want to note is, in a way, the most important and the most overlooked thing in basically all papers. And it's the part where they say limitations or conflicts of interest. And here, someone who I presume is Soberg's advisor, Camilla Shield, declares that she works for Novo Nordisk in BAT biology. And another person says they work for another biotech company, and, quote, all other authors declare no competing interests associated with this manuscript. Now, I'm not certain why working for Novo Nordisk would or could be a conflict of interest, but it's worth noting that according to Susanna Søberg's LinkedIn, she took a job at Novo Nordisk in June 2021, just a few months before the paper was published. So something maybe is going on there. But even if that is not a problem, and I'm not saying it is, there's a much more serious conflict of interest than those declarations as far as I'm concerned. How can you trust the results of scientific research when your financial well-being is directly correlated with your results? This is the very definition of scientific conflicts of interest. If you read her article as strictly as I just did, then it's clear that cold water swimming has some sort of biological effect, but it's not totally figured out yet, and we should be very careful putting too much weight on any of the results. That's what she says over and over again. But that statement, that very measured statement, is not what Susanna Søberg is saying in public about her research. Instead, you can see her posing in front of icy lakes with the cover of her magazine, proclaiming that she understands the science of BAT better than anyone else. She claims that breathwork, sauna, and ice protocols that she developed will fix anxiety and depression, never mind the fact that her study was, at best, just about energy expenditure and cold water swimming.
All of which are scientifically proven tools and put together in an approach that I see is most efficient.
She says that she knows the optimal times for being in a sauna or being in ice water, and yet those times just come from the people that she happened to be studying, which she obviously has reduced and cherry-picked parts of her data. You know, when I think about what optimal is, I usually think that somebody has studied, like, say, a range of different protocols in ice water and found which, timing might produce, I don't know, some sort of clinical endpoint. But that's not what she did. All she did is said, I did a paper where I measured people who were in water for 11 minutes over the course of a week, and so therefore 11 minutes must be optimal. But she has no control group whereby she is comparing this against. So there's no basis to say that she knows at all what's optimal.
This is of course not a scientific study, but simply my evaluation based on how I know biology works.
Now, what she's really done is just place a veneer of scientific credibility on a practice that people in Denmark and all over the world have been doing for a long time. And then she's selling an online course, her Substack, and a series of cold exposure books as she appears on mainstream magazines and as the face of the science of brown fat, even though her results are far from conclusive. She's a science influencer now. She's not a scientist. Shortly after she was on the Huberman Lab podcast, she resigned her position at Novo Nordisk and now has no academic appointment whatsoever and focuses entirely on the Soberg Institute. In fact, this is like a trope sort of across the board. Many of the people that we, the lay audience, look to for scientific certainty are not actually scientists anymore, even though they might have like a PhD or an MD. Andrew Huberman, who gets a lot of things right on his show and is measured a lot of the time, also frequently delves far outside his expertise and gets a lot of pushback from scientists who are experts in the areas that he pontificates on, sort of ad lib.
Yeah. Susanna Søberg, I think one of the best scientists in terms of deliberate cold exposure and its benefit.
Then there's Dr. Rangan Chatterjee, a British physician who has declared that ice baths will prevent you from ever getting sick again. Now, I'm a proponent of ice baths, but that's just bullshit. There's also people like Mark Hyman who say that it's possible to become almost immortal and reverse your aging through his nutrition hacks that you could buy on his website. It's all flim-flam with a scientific veneer where you have a degree on your wall and you say, because I have this degree, you should listen to whatever I have and then buy my course. Sure, it's true. They can pull on a few promising clinical studies and a few pieces of data, but then they go off script and they just want to crank up views and sell more books and more e-courses. It's a problem all across the internet. And you should know, here's some self-disclosure here, that I am an ice bather. I have written books about cold water and breathwork, and I've spilled a lot of ink on the promising science of brown fat when I was writing What Doesn't Kill Us back in 2015. It came out in 2017. But in What Doesn't Kill Us, I was careful to note that the science at that time was still far from settled. In fact, at one point, I highlighted a highly problematic study for BAT enthusiasts. It was the study on Wim Hof, who's the famous ice swimmer who's been swimming in ice water for like 40 some odd years, and his genetically identical twin. Yeah, that was a coup for science. They took both a Wim, the forever cold water guy, and a truck driver who had basically no cold water experience, and they compared both their BAT in PET scans, and they found that they had the same amount of BAT. Like, you would have expected that the guy who was in ice water all the time would have vastly more BAT, but nope, that's not what the studies said at all. In fact, their BAT was the same. This maybe just comes down to genetics in that case, because maybe cold exposure doesn't increase your BAT. It's a sign that maybe BNT isn't really the critical factor in ice water that we want it to be at all. Now, here's the rub. I am not against cold water, sauna, or any of that. In fact, I do that all the time. And you can like sauna, you can like cold water as a practice simply because it makes you feel better about things. Because it's something you can do with your friends, something that doesn't involve alcohol, that it makes you happy. All of that's great. And it's why I do ice water swimming. These things don't need to be poorly explained and monetized by health influencers who have a vested interest in telling you that they are the only ones who really understand cold exposure. We as humans have been doing this for a long time, and we get a benefit out of it, even if it can't be directly measured. It could be that the perceived benefits of cold exposure simply come from the fact that it forces you to feel something. We spend so much time indoors, isolated in our indoor environments and our temperature control, that doing something hard fires up our senses and makes us pay attention to our bodies. It makes us feel alive, and these experiences are powerful. As Otto Music wrote in one of his papers, this stuff, these sensations, are probably the core part of what the placebo effect is altogether. And it's okay just to leave it there. We don't need to come up with scientific sounding mumbo jumbo to say that ice bathing is meaningful. And we certainly don't need to spend $2,500 for the honor of learning something that should be free. I have a problem with this sort of parallel science. Like, it's science sounding words and studies that are sort of ill-conceived, and then pretending that those results say something that they don't actually say. So Susanna Søberg, honestly, she's probably a really nice person. I probably would even enjoy going for an ice bath with her. But I feel weird about her position of using her degrees as a way of selling you this idea that she knows something about ice bathing that other people don't, especially when her data is so problematic. From Pokey Bear LLC in Denver, Colorado, this was Magnetic North.